marks the second anniversary of IHub-Data, and it also coincides with the silver jubilee of IIIT Hyderabad. It is our proud privilege to offer to you the Symposium on Data-Driven Deep Disruptions at IIIT Hyderabad. International Institute of Information Technology, Hyderabad, is an autonomous university founded as a not-for-profit public-private partnership in 1998 and is the first IIIT in India under this model. Over the years, the institute has evolved strong research programs at undergraduate level with an emphasis on technology and applied research for industry and society. IHub-Data is a technology innovation iHub for data banks, data services, and data analytics established by International Institute of Information Technology, Hyderabad, under the National Mission on Interdisciplinary Cyber Physical Systems Scheme. iHub manages the Data Foundation, Research and Technology Development, Applied Research and Translation, HRD and Skill Development, Innovation and Startups, and the international collaborations to strengthen some of the core objectives and goals of IIIT Hyderabad. Please enjoy participating in this symposium. I would now like to introduce to you Dr. C.K. Raju sir. Dr. C.K. Raju sir has been working as a lead faculty of skill development courses in IHub-Data, IIIT Hyderabad since 1.5 years. He has done his PhD in National Institute of Technology, Kharagpur, and Masters of Science in BITS Pilani. I would now like to invite Professor C.K. Raju sir to introduce to you the president of this inaugural function, Professor Deva Priyakumar sir.
Thank you, Lakshmi. So Lakshmi is our heading the careers portfolio. And we all know in Indian mythology, Lakshmi is the goddess of prosperity and wealth. So it's a very auspicious day for all of us. And I welcome all of you who have come here from far to be part of this 3-day symposium. Have a nice few days ahead. So let me now move on. We have three great people, three giants in their fields who are here to inaugurate this 3-day symposium. Professor Deva Priyakumar is the head of IHub-Data, and he has received his PhD from Pondicherry University and Indian Institute of Chemical Technology. He had a postdoctoral fellowship of University of Maryland at Baltimore, US. He's the professor and head of the Center for Computational Natural Sciences and Bioinformatics here at IIIT. For his contributions, Professor Deva has been recipient of many awards. A few of them are, he has received the award in from the Chemical Research Society of India, from Chemical Society of Japan. He was the Google Impact, he has also received the Google Impact Scholar Award. He was also the Young Scientist recipient of the Indian National Science Academy, and many other. Okay, so let me now invite Professor Deva Priyakumar to be the president of this function. Professor C.V. Jawar is the Dean of Research and Development at IIIT Hyderabad. He is also the head of Center for Visual Information Technology and leads a group focusing on computer vision, machine learning, and multimedia. He's an Amazon Chair Professor and is also an elected Fellow of Indian National Academy of Engineers and International Association of Patent Recognition. He has a large number of publications which people don't count. And he's this is what makes Professor very special, Jawar very special, which is that he is extremely conscious of the social and practical relevance of application of the research that takes place here. And he is also actively engaged with several government agencies, ministries, and leading companies in the world innovating at scale through research. The Association of Computing Machinery, ACM, in recognition of his contributions to teaching, has awarded him with the ACM India Outstanding Contribution to Computing Education Award in 2021. May I now invite Professor C.V. Jawar to take the stage. Our chief guest for this day is Professor Devi Ramaswamy, who was the former head of Philips India. He is now the CEO of RV Consultants. He advises global and local healthcare enterprises on strategy growth and diversifications, as also on product and project management. He is on the board of several incubators, startups, and educational institutions. He also coaches and mentors senior leaders in the ecosystem. At Philips, he was the senior director and head health systems at Philips Innovation Campus at Bangalore. In addition to this, he also managed a new business creation hub, which interfaces the markets in Australia, Japan, APAC, India, Middle East, Turkey, Africa, and Central Eastern Europe to support their growth ambitions in healthcare solutions. While product development for the developed world was his forte, he is also deeply involved in creating CE and FDA certified products and solutions for the underserved segments in emerging geographics. After graduating from VNIT Nagpur in electronics and power engineering, he joined L&T in '82 and later moved to GE in 2000 and then to Philips in 2010. His experience covers research and development, operations, finance, strategic planning, project management, product management, mergers and acquisition, and general management. He completed his master's in engineering management from NIE Mysore in 1990. In his career spanning 4 decades, he has spent over 25 years in the healthcare space, evangelizing affordable care. Dr. Ravi has been a task force member of several government committees at the central and state level. He is a regular speaker in Indian and international conferences on healthcare. He evangelizes healthcare in the print and digital media. He is a fellow of Institution of Engineers India, fellow HIT Lab, USA, a senior member IEEE, member of FICCI Innovation Subcommittee, member CIA, and chairs the healthcare track for IET in India. Let me now invite Dr. A.V. Ramasamy on this slide. I now request the President of the function, Dr. Deva, to speak and lead the function.
Yeah, thank you, Dr. Raju, for nice introduction and putting together this program. So, first, before I forget, I would like to thank Dr. Raju and also Pawan, who is not here, maybe outside, but for putting this 3 days program together and then, making this possible. So I also would like to welcome all the guests from outside, the panel members, speakers, and also the students from other places and other companies. Right, so what I will do is maybe I will give a short introduction to the IHub-Data and then mention few things that we have done in the last 2 years, right? And then, hopefully we will get some feedback and, possible more collaborations and partners working with other entities. So IHub-Data, we started this about 2 years ago with the mandate of coming up with new technologies based on, data. Like, we have data that is collected whether from hospitals or mobility-related data, and to develop new technologies that can be productized or that can make an impact in the society, right? So, initially we had a lot of plans and, a lot of brainstorming and, especially Professor Jauhar, so he has a very clear vision of how this has to be done. And hence we put together different kinds of verticals where we do, for example, the basic research and then data collection and data activities around data through something called a data foundation. And then, when you have these new technologies, we develop new products and prototypes that possibly the industry and new startups will use of it, or we apply in industry. So in addition to this, we also have different programs which Dr. Raju leads. We have, for example, the courses that we do, like long-term courses that some of you are part of, the Foundations in Modern Machine Learning Methods, and then we also did a course on AI for drug discovery, and then many are in the cards, right? So basically the idea is to reach out to as many individuals as possible, or reach out to as many institutes as possible to bring awareness and skill to students and other technicians in data-driven technologies, right? Whether professionals in healthcare or students who are doing their engineering or they have graduated and they would like to do something and so on. So and then the next thing that we do is to train, do hands-on training, and people are part of active research projects here, right? Through, it could be internships, it could be Masters by Research Program fellowships, or PhD fellowships, postdoc fellowships, and so on, right? And also, now that we are out of COVID, we'll also have, visitors coming in. There are a few visitors now, but visitors coming in and, from other colleges or companies and so on, spending time with us and then be actively part of the efforts that we do or some of the initiatives that we do. And some initiatives are done by others and we, mentor them and be part of it and so on, right? So, so that way, we have a number of opportunities at multiple levels, whether if you're a student or whether you're leading a company or leading an institute, we have a spectrum of different activities that many, different levels participation could be sought in this particular activity. So just to quickly mention some of the initiatives that we have done in the last 2 years. Most of our work is in two different verticals. One is in healthcare, second one is in mobility, smart mobility. So the smart mobility is an area that we started working in maybe around 5 years ago, but then we expanded significantly after the IHub started. So this particular area is driven by Professor Jawahar and his large team. Some of the things that we did was we have put out the largest data set on Indian driving conditions. For example, people talk about autonomous driving, right, in the West, right? And that same kind of technologies is not going to work for the Indian setting, right? So, instead of thinking of autonomous driving, can we think of, for example, road safety, right? Can, this large number of, the fatality on the roads in India is a big problem, right? So the question is, can we come up with technologies, right, that can reduce the fatality by, let's say, 50% in 5 years, okay? So in that sense, his team has developed a large number of technologies, including, road quality assessment and road surveillance, detection of, potholes, for example, and detecting traffic violations, like whether it's signal jumping or, helmetless driving, or 3 people riding on a motorcycle and so on. So now all that technology that is developed can be used to automatically detect all these things, okay? So in addition to that, there are multiple other projects that the mobility team is driving, which I think you will hear in the next 2 days, some of them, and I hope Professor Jawahar also may mention some. And the second area is healthcare, where again, some initiatives we have started. So one of them is we have established a genomics sequencing lab. Basically, this lab will try and do a disease surveillance or genomic surveillance of infectious diseases like dengue, COVID, and malaria, and so on, right? So we'll have a large data set of the different kinds of the genome sequence of different kinds of organisms and how the mutation happens, in which area it's spreading more and things like that. And the second area is again that is being done is in cancer diagnosis, where Dr. Vinod here, he leads the faster and accurate detection of cancer based on, for example, whole slide images, right? We have again established a facility here, and then also in NIMS Hyderabad campus and so on. And then the other areas that we work are in mental health and neuro and mental health, where Dr. Srijitesh is part of. We are looking at sleep staging and other different kinds of projects. And then we also did a lot of work in COVID-19 to, for example, for predicting mortality, right? If somebody is infected with COVID-19, how likely or how is that person likely to survive, right? So that kind of work, again, genome-based work and things like that. So as I said, basically the idea is that we have been doing large amount of data collection in healthcare and mobility and trying to develop technologies that could be useful in disease detection or improving road safety and so on. So what we aspire to do in the next 1 or 2 years is one, of course, to expand different of these different activities. I hope in that sense we will have some inputs and more partnerships coming in, and the next important thing is to take products to the market, to be able to develop some prototypes and products and so on that actually can make a difference in the day-to-day life, right? So that's the hope for the next step. So I hope I was able to kind of mention a few things in terms of what we have been trying to do and what we aspire to do. So with that, I leave you, I hope you will have 3 days of very good learning and interactions and so on. So I wish you all the best. Thank you very much. Thanks. Okay, so now I would like to invite Professor Jawahar to say a few words. Thank you.
Thank you, Deva. Thank you, Raju. Good morning. There's some. Okay, good. These are all living human beings sitting here. Good. So I have a couple of questions before we get, and I want to know the answer for what you understand. That's the primary objective. One, there are two things that you heard. One, I think Professor Raju has been talking about is data-driven disruption. Now, what is this data-driven disruption? Okay, it's a bit tough question. So let me ask an easy question. You might have heard this story or a very popular phrase everywhere. Now, data is a fuel. Of what? Of the next century, this century, AI, everywhere people use this data is a fuel. What does it mean by data is a fuel? Why is it called data is a fuel? Or data is oil, or whatever the people call it, isn't it? Why is it? What does it mean? You need data to work on anything. So which means like without fuel, without oil, nothing will work. That's a parallelism. Good. That's one good comparison. So always when you hear a slogan like this, understand how deep could be that analogy. Is there any other analogy that you can have with fuel or oil with data? What is oil? Is it this oil that we apply on our head? No. What is this oil? What is it? It is. What is it called? In the market, etc., where we go? Petrol, diesel, all these things that we do, isn't it? So how they are produced? They are extracted by what? Digging some well. Okay, so what is there below this earth then? Okay, so how they came? What was there? One person, little bit loud. Yeah. Pardon? Export. What does it mean? Bodies exported. What is bodies? Okay. Yeah, very tough, powerful statement. True. So one civilization possibly like left lot of things behind for us to enjoy. That is what data does. You leave data, the residue left, so that you can do things on top of it in the future. Or you use such left outs of the previous civilization or our friends or our colleagues or our previous generation for building solutions for the next generation. Look at how powerful is this analogy. Which means that, so now why is this available only in certain places? Good to ask, think a little bit. So on one hand, we all create tons and tons of data, isn't it? So when I walk, when I move, when I breathe, when I live, every day, every second, every millisecond, microsecond, I am creating data. And everything that you do, type, click, or browse, everything that you are creating data. Every sensor is capturing data. So what is the data that people use? What happens after that? What is really useful? Pardon? Yes. By using the data, we can do that, but not all data gets used. So you also need to have an idea about, yes, you are right. I think it is not that we have data. Now we also need to know that what data we need for certain type of applications, solving certain problems, etc. in the future. And this requires data to be generated in certain form. Certain type of things will work now, certain type of things will work without, maybe after many more years, with so much of density coming, maybe at some stage, we will also see oil in Hyderabad. But today we don't have, because environmental factors did not really help us in that. So when you create data or when you use data, you also ask the question. So sometimes we look at this as a disconnected piece in the conversations I see. So say I have data, then why problems are not getting solved? Say somebody was asking last week to me, say that, Jawar, you've been talking about there is no data, but there's a lot of data here, why are you not using? It is that sometimes we are not ready to use it, sometimes we don't know how to use it, sometimes it is not curated enough how to use it. It is not that data is just some log. You are able to learn from the data because it captures some knowledge of the process, of how the physics and science behind how it was created, or the knowledge of the civilization captured in some form, encoded in some form in the data, so that you can build AI systems on top of it. It may be an expert, it may be a layman, we put knowledge in along with the data. So this gap sometimes we have to understand. So very often we look at data as a log or data as a dump, so my hard disk is full, it is full of data. Does it mean, on one hand you are right, your hard disk is full with all the movies that you download or watch, it's okay, but all the photographs that you have taken is full on your mobile phone, it is full of data. But that data you are not able to use it because it is not rich enough for you to use it today. So this is exactly similar to the way we say, I can write 10 million lines of Python code by sitting here. It will not compile, it will not run on my computer, it is of no use to anybody, isn't it? So it has to be in some form that this code, this data that I generated, I need to use it. So there is an eye on how do I use it when you are creating data, when you are using data, when you are curating data, when you are talking about data. That is why the data in its purest raw sense, if you measure it as a number of bytes or amount of bytes that you have, is of not useful for us. But the moment you connect with the utility, The moment you can see a utility, so you can have no visibility. So for example, I want to go from here to like a Koti, and I start walking with no direction, I may not reach there. Maybe I will reach eventually by doing a random walk. But if I have a source, like a goal, that goal tells me how should I walk. The goal tells me I should walk from here to this direction to reach Koti. But I cannot walk in this direction because there is a wall on the way, there are buildings on the way, I cannot walk. What do? I take a road route, which may go this way, finally take me to the route. Similarly, in the case of data also, I have a goal, what data I want, what problem I want to solve. I have some vague understanding of what I want, so I need to move in this direction. So there are two ends here. There is a goal. There is a goal of solving problems which are very important, which will disrupt the world, the existing setups, which will solve important socially relevant problems. This is one viewpoint. And for that, we need data. Now, we may not know how we use this data to reach there today fully. If I am able to see the end of the goal, so if I am able to see from here that the route to the Koti has to be quite close. If you are looking for full visibility to your goal is very near. This makes the life difficult. So you have to have visibility. With no visibility, you will be in the dark. With full visibility, you are looking for extremely low-hanging fruits. Very small, achievable goals. So you have to be comfortable in thinking, how do you live in between these two? There is a goal, I have a data, so what data I need to curate and how do I take it to this place? And that is what today happening in the AI space. People are creating data. People are curating data. People are making this data available. And this world has changed a lot. I don't know how many of you are aware of the history of, or at least the recent history of computing if you look at it. At one stage, we were worried about the softwares that we are writing, using, building are proprietary. There's a strong movement came, open source software. You might have heard this, open source software, isn't it? Today everything is open source. It did not meet the goals. Open source is not enough today. It is not the code. The knowledge is in the data. So people are not today worried about releasing the code publicly. Not just academia, industry, everywhere, companies. Companies are investing on commercial big entities will fund a lot of open source activities. They are not losing any IP. It is the data that is important today. Systematically that entire thing changed. Now, is the data proprietary? The next question going to come. Today, if you ever want to disrupt, if you ever want to solve problems, what is important? There's a very well-known public trick that people are using today. I open source the data. What is open sourcing the data? Makes available. What happens after that? All of you work on that. Okay, earlier I was limited by my skills, my time, my computer and everything. Now with this open sourcing the data, I am able to get all of you on board. Our team has grown. We can solve now tougher problems, important problems, bigger problems. So the way the data is going to disrupt is in many different ways than what you thought. It is going to get people on board. It is going to strengthen the team. It is going to strengthen the team without paying salaries. I conduct a hackathon, all of you will solve, and I just need a single prize money which is worth of one person's salary for 100 people to work on it. Nice? Nothing wrong. The learning is much more. As an educationist, I appreciate it because all of you are learning in this entire process. Working on real life problems used to be a worry many years back. Today that is not a worry. Even today I see old people still sometimes talk about working on real life problems, etc. I say, look, today young generation works only on real problems. Why? Because they use the data from Kaggle or similar places. So situation has changed significantly over the last many years. And we have to appreciate that change, and we are all getting ready for disrupting the world with the help of this data and technology. Many years back, it used to be very difficult for us because we will say, oh, I'm not trained for that. My college is not teaching me this, that. This algorithm is not known to me. This book is not available to me. This journal is not accessible for me in my college. All of them have disappeared today. We all have, so when we are all PhD students, it takes 3-4 years for us to get the latest journals because all printed copies coming, shipped from somewhere, etc. So there is nothing like that today. You get it, papers, before it gets published freely on the web. You come to know the latest research everywhere very easily. So you have all the open source code available today. All the collabs and other people are going to give you the hardware, computing facilities if you cannot afford to do it today. This is time for you to work on our local problems and create disruptions and advances in the country. We are at the right time, and I look forward for all of you to be part of this. Thank you. So I invite the chief guest to speak.
Thank you very much, sir. Respected Professor Raju, the faculty and the leadership here at IIIT, Professor Deva, Professor Jawahar, and students. First of all, I would like to sort of place on record my thanks for having invited me here and giving me this opportunity to share my 2 cents. Over the last 30 years, I have been evangelizing healthcare, and that's possibly the only thing that I know that I can talk about. And I'm really going to take a cue from you, Dr. Jawahar, in terms of how you actually ran the session. So this is going to be a sort of an interactive session. I'm not going to let you guys be at peace with yourself, okay? Trust me. 1978, 230 countries came together to pledge for having primary care available to all its citizens by 2000. 22 years have gone by. 40 years from the time the pledge was taken, and we are nowhere even close to it. Right? Now, let me turn it around and ask you a few questions, guys. Why is this data science, why is this AI so important for healthcare? We will derive out of the answers that you actually give me. What is the world population today? How much? 8 billion. Okay. How many of them are over the age of 65, the senior citizens? Take a stab. Take a stab. It's 1.3 billion. How many people out of this 8 billion will have cancer in their lifetime? Given all the good stuff that we are had, eating packaged food, sedentary lifestyle, all of the good things, drinking, all of the things that is happening, what do you think is the ratio that is expected to be in the world? It's 1 in 3. How many people are going to be diabetic in this world? Take a shot. 1 in 6. How many people are having respiratory problems in this world today? 500 million. How many people are having hypertension problems? 1 billion. Okay? How much of money is America spending as a percentage of GDP on its healthcare system? 18%. How much is Japan spending on its own system, given the fact that there is a double whammy there in terms of decreasing birth rate and enhanced longevity? 16%. Now, if you look at all of this, you will find that the problems that we are having are massive. Any amount of investment in access in infrastructure is not going to be sufficient to solve the problems that we are looking at. We need to look at exponential solutions for this. Now, take the case of India and other emerging world. What are the 3 challenges that we have? It is cost, quality, and access of care. If we look at the number of radiologists that are available in India, it is 1/5 of what is, 5 times short of what is needed. We know that intensivist in an ICU, intensivist manages care, right? Do you know for a population of 1.3 billion in India, how many qualified intensivists we have? Take a guess now. What is it? How much? Number of doctors managing intensive care, qualified doctors managing intensive care in India for 1.3 billion population. I want an answer, guys, otherwise I am not moving forward. 1:5 or 5:1? 1:5. The answer is 500. Okay? Indonesia, 280 million people. You know the amount of intensivists Indonesia has? It's 50. Now, when you are looking at these sort of problems, you will find that any amount of investment in infrastructure is not going to take you to where it ought to be. It is going to be in terms of technologies. And that's the need, and that's where AI and ML and what have you, the upcoming technologies, have a significant role to play in dispensation of care. Now, what is an exponential technology? Exponential technologies are those for which the input is small but the output is massive. You walk across the room, you take 30 linear steps. You go from possibly one point of here to the other end of the room, right? If those were to be 30 exponential steps, I would have walked the distance from here to moon 26 times. Do the calculation and check it out, it works. Now, that's the type of technology that we need. Now, to draw an analogy to what Professor Jawahar said in terms of, let me sort of take that to a real life world. We started, you know what a CT is, right? It's basically a scanning system. We first started with 8-slice CT, then we went to 16-slice, then we went to 32, 64, 128, and Toshiba brought in a 256-slice CT, and everybody, hey, ha 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 ha, it's a big one. It's like having a 50 MB megapixel camera with me. But at some point in time, this race for advancement in hardware has stopped. Nobody cares what the hardware is, because be it Siemens, be it GE, be it Philips, anybody else, the actual inferencing that happens is from the image that comes out. And that image quality is almost the same for any of these devices. The question that comes up is, what do I infer from that image, and how do I draw, shall I say, inferences which will help me treat the patient better? And that again is all about data and data manipulation. We had another problem in hand saying the customer requirement was, take MR as a case in point. A standard MR, if you were to do a brain scan, it takes you about 40 minutes. Doctors came and told us saying that 40 minutes is not sufficient, we need to do it in 20 minutes. So what do? You've got two options there. Either I accelerate the hardware or bring in software techniques which will ensure that I am able to reduce this time. If I were to take hardware, it's going to take me millions of dollars of investment and time to make it. So what did we went the easier route? We said, let's do it software. So what I will do is, instead of scanning it for 40 minutes, I will do it for 20 minutes only, and for the balance 20 loss, I will recompensate it by algorithms that will get it back to where it was. So effectively what you get is the same quality of image in 20 minutes, which again is tantamount to data processing. Which only means to saying that at some point in time in the future, the devices are going to become agnostic. It doesn't really matter whose device you use, the power is in the data, the power is in the inferencing. And that's where you guys come and play a role. Let's take another example. Let's take, for example, maternal care. India has a death rate that is, for every 100,000 births, what are the number of children that we lose? India is at 53. Sub-Saharan Africa is at something like 250. Japan is at 1.8. Can we use simple techniques? Can we use predictions by monitoring the normal parameters of a mother post-conception? And can we sort of manage neonatal rates? The answer is yes. Did we do it? Yes. Indonesia, we brought it down to 0 by driving certain interventions from home. Absolutely basic interventions. And that's the power of data if you were to have all of it with you in the right form, in the right manner, because most times, as again what Professor Jawahar said, data, what you get to see is a bunch of data. The question is there something that I can draw an inference from? Is there something that I can make a meaningful use out of it? And that's where you start looking at structured data. So all in all, I would possibly, it suffices to say that the future of healthcare, at least for sure, is dependent on the way that we take data, interpret it, and also draw conclusions from, shall I say, from a multimodal perspective. Like, there was an analysis done saying, by taking a camera shot of your retina, if the neurons in the retina are affected and there are similar neurons in kidney, the chance of collateral damage in kidney cannot be ruled out. Now, that's the type of inferencing that we need to bring to the table. And that is the ask, my friends. There is so much to do in healthcare. The problems that we are dealing with is so huge that conventional methods will not help us. And that's where I really look up to this generation to stand in and see what you can do to collaborate with the hospitals, collaborate with the clinicians, to come up with solutions that will take mankind to the next level and make all of us feel safe. Once again, thank you so much for sharing this, for giving me an opportunity to share, and looking forward to teaming up with you guys. Thanks.
Inaugural session. I thank all the speakers for enlightening us with this new words of wisdom, and we hope to see more such interesting sessions in future. Thank you, Professor Jawahar. Thank you, Professor Deva. Thank you, Dr. Ravi Ram. We'll break for its tea and